Welcome back. In this video, we're going to compute the squares of the angles in degrees between 1 and 90 degrees. We can write this sum in sigma notation as well and as in this expanded sum. Here, sine squared of 1 in degrees plus sine squared of 2 in degrees plus sine squared of 90 degrees. Okay, in the rest of the video, I will ignore this square or degree notation, but don't forget that when I write sine of 1, that means that 1 is in degrees. It's different when we write it in radians. So therefore, we have to keep that. If I forget the degree notation, I mean that I am computing the sums in degrees. Okay, so here there is an easy way to compute this sum. We can use other techniques, but the easiest way, I believe, is that to use two facts. So the first one is we know that sine squared of x plus cosine squared of x is 1. Okay, the second thing is that we know that the cosine of 90 minus x is sine of x. Okay, here I mean degrees. We can use these facts to rewrite this sum, and after that we add the two similar sums and we divide by 2 to get the value. Okay, so let's call this sum here a. So here a is the sine squared of 1 plus sine squared of 2 plus the sine squared of 90. Remember that 1, 2, and 90 are in degrees. Okay, I can use this first fact here. So the sine of 1 is going to be the sine of 90 minus 1, which is the cosine of 89, pardon me. So here I can write this one as the cosine squared of 89. Note I get the 89 from here. So here x is 1. Therefore, cosine of 90 minus 1 is 89. And therefore, this sine is squared. I have to square the cosine as well. Next one is the cosine squared of 88. And I'm going to keep going until the one before the last, which is the cosine squared of 1. Okay, this one is coming from 90 minus 89. Okay, plus the last one, which is the cosine squared of 0, because here I have x is 90, and therefore 90 minus 90 is just 0. Okay, so I'm gonna keep, okay, let me write it one more time. So I'm gonna keep these last two numbers, okay, in this sum. So I'm gonna write this one here one more time, just to see where I get this sum. So here, sine squared of 2 plus the sine squared of 90 here. This second one, I'm going to start from this last here, before the last one. Okay, so I want to use or make profit of this one here. When I have sine squared of 1, I need to have the cosine squared of 1 here. Okay, therefore, I'm going to start from here. So I'm going to have, in the second sum, so I'm going to have the cosine squared of 1 plus cosine squared of 2. I'm going to keep going until the one before the last, which is cosine squared of 89 plus cosine squared of 0. Okay, now we can use this rule here comfortably without worrying about anything, because I have the same x. Okay, before I didn't have the same x. So now I have the same one here, 2, 2, 3, 3. And here I have the sine squared of 89. Okay, so if I sum up until here, I'm not going to get until 90 and 0 here. I'll keep them until the end. Here I have a plus a is 2a. And I have sine squared of 1 plus cosine squared of 1. Okay, this is my first sum. Next, sine squared of 2 plus cosine squared of 2. And I keep going until 89. So here the angle 89. sine squared of 89 plus cosine squared of 89, and I'm gonna add these two now. So the sine of 90 is 1 and the cosine of 0 is 1, therefore this is 1 plus 1, which is 2. Okay, this is special. Always when you have these sums, you will have some special numbers. You have to be careful of that. Here now I have this sum. 2a is, what's this one? 1. What's this one here? 1. I'm using this fact here. Okay, and next I'm gonna use the 1 before the last one. Therefore I have 2a is the sum of these ones. How many 1 do I have? So I started from 1 and I stopped at 89. Okay, I have 89 ones. Therefore I have 89 times 1. So 89 times 1 plus 2, which is 91. Therefore a is 2a is 91. Therefore a is 91 divided by 2, which is 45.5. So my sum is 45.5. This is the sum that we have, and we have proved it. Okay, so this is the I believe the quickest way and easiest way is to use this one here. If you want to use something else, you can use complex analysis, okay, or transformation of this one here to the cosine. Okay, so we know that the cosine of 2x is 1 minus 2 sine squared of x. Therefore, if I add minus 1 to both sides and I divide by minus 2, I'm gonna get sine squared of x is 1 minus cosine 2x over 2. Okay? So here, if when I get rid of the square, I can use this fact here. And I can solve it, I will get the same result. If you don't like this one here, you can use the fact that sine of x is e to ix minus e to minus ix over 2i. Okay, but this is longer. Okay, you will get the same result, but this is longer. But we will get stuck into some complex computation. This is I think this is the easiest way. Using it this way, using these two facts, okay, will definitely get you the result that you need. Okay, thank you very much. Have a great day.